For topic 4, we're going to look at the multiplication property of inequality. And in some ways, it's very similar to the multiplication property of equality for linear equations in one variable. It's similar in the sense that it allows us to multiply and divide both sides of the inequality, but there is a huge glaring difference, okay? So you do have to use a little bit of caution in that very, very last step of solving an inequality. Otherwise, solving inequalities, linear inequalities in one variable is exactly the same as solving linear equations in one variable until the very, very last step. And then there's just one little difference. So let's kind of do a for instance. Let's think of something that we absolutely know to be true. So let's say we have 2 is less than 3. I think we can all agree that 2 is in fact less than 3, okay? Now let's choose some number. Let's choose a number, we're going to call it C. And let's choose a value for C that is positive. So let's say we choose C to be 1. Okay, 1 is positive, right? So if we took both sides of the inequality and multiplied them by 1, what would happen? Well, 2 times positive 1 is 2. 3 times positive 1 is 3. 2 is still less than 3. Okay, so that seems easy enough. Now let's try another value for C. Let's try, I don't know, we could try anything. Let's try 15. Okay, 15 is positive. So if I take 2 times 15 and I take 3 times 15, well, 2 times 15 is 30. 3 times 15 is 45. We still get a true statement, as in the left is truly less than the right, okay? Because notice, to begin with, we said 2 was less than 3, so the left was less than the right. We still have a situation where the left is less than the right. So let's take another situation we know to be true. Let's just go ahead and stick with the 2 is less than 3. That's actually easy. But this time, let's choose a value for C that is less than 1. So let's start with something easy like -1. Well, if I take 2 and I multiply it by -1, and I take 3 and I multiply it by -1, I get -2 and -3, but can I still use a less than symbol? And the answer here would actually be no. I can't use a less than symbol anymore because -2 is not less than -3. So the left is no longer less than the right. -3 is less than -2. And I know this because if I look at a number line, -3 is further away from 0. So to the left of 0, the further away you are, the smaller you are. Okay? So let's try this with another number. Let's see if another number works. So let's say we do C is -10. So if I take 2 and I multiply it by -10, and then I take 3 and I multiply it by -10, I get -20 and I get -30. So can I use a less than symbol? Because remember, we started out with 2 on the left is less than 3 on the right. Well, I can't use a less than symbol again because -20 is not less than -30. -30 is further away from 0 on the left, so -30 is smaller. So now we would have to say, well, the left is greater than the right, okay? So the big thing here is if you multiply or divide both sides of an inequality by a negative value, you must reverse the direction of the, I'm almost out of room, inequality symbol. And I would love to tell you that there's going to be a bell that's going to ring or a beep that's going to beep or a gnome that's going to come out and yell at you. But you just have to, as the mathematician, you just have to remember this, okay? So if you multiply both sides of an inequality by a positive value, you're fine. You don't have to do anything to the inequality. But in that final step, if the coefficient on your variable is negative, that means you're going to multiply or divide both sides of the inequality by a negative, and then you have to reverse the direction of your inequality symbol, okay? So let's kind of read through what I have typed here. I state that this property allows us to isolate a variable by multiplying or dividing both sides of the inequality by the same non-zero constant. Okay, so you can multiply both sides by the same thing as long as it's not 0. Now, we're going to let A, B, and C be real numbers where C is positive. So I'm just showing here that if you multiply or divide both sides of this true inequality, A is less than B, multiply both sides by C or divide both sides by C where C is positive, nothing happens to your inequality symbol. It's going to remain intact. Okay? Now, if we let A, B, and C be real numbers where C is negative, if you have that A is less than B and then you multiply both sides by a negative or you divide both sides by a negative, you're going to have complete sign changes. And to compensate for those complete sign changes, you, the mathematician, have to reverse the direction of the inequality symbol. Okay, so that's what I have here. All right, these rules apply again for all four inequality symbols. So no matter what you start with here or here, the rules are going to be the same. Okay, so let's practice this one. All right, for example 4, it says solve each inequality, write the answer in, again, interval notation, and then graph the solution. So interval notation and a graph. So please read the directions for inequalities really carefully to make sure you know what all you need to include in your answer. All right, so I'm going to rewrite this one just so I have plenty of room. I have 1/3 x is greater than 2. Now, when you're multiplying or when you're solving an inequality or an equation and the coefficient on the variable is a fraction, you can do a couple of things. Okay, you can try to clear the fractions first. That's fine. Okay, we know how to clear fractions. You can clear fractions for inequalities as well. Or if you just have this one single fraction like what we have here, you can still just solve for x. You could divide both sides by 1/3. That would be fine. Or the trick is you can multiply both sides by the reciprocal of 1/3. So the reciprocal of 1/3 is 3/1. All right. And it just so happens that if you multiply reciprocals, their product is just going to be 1. And that's kind of like the definition of a reciprocal. Two numbers are said to be reciprocals if they have a product of 1. Okay? So 3/1 times 1/3 ends up being just 3/3 or 1x. And then if I have 2 times 3/1, that just becomes 6/1 or 6. There were no sign changes. I didn't have to do anything weird to my inequality symbol. All right, everything is good to go. We were multiplying both sides by +3, so life is copacetic, okay? We want to graph this now. So we're going to draw a number line. We're going to indicate where our end point is. I'm going to say it's here this time. All right. And then we have to ask ourselves, can I include exactly 6? And the answer is, well, no, I can't include exactly 6. So I can be anything from 6 and up as long as I don't include exactly 6. So I would use a rounded bracket here to tell the reader that, hey, we can't include 6, but we can be anything bigger than that. Actually, let me use red again. So we're going to shade to the right to indicate that we can be anything bigger than 6. Okay? And then this red piece is your interval from the far left. The lowest value we could be is 6. To the right, the highest value we could be is infinity. We can never include infinity. And in this case, we cannot include the 6. So that is your interval notation and your graph. Okay? Now, for part B, we do have to be careful with part B. Part B says that we have -8x is less than or equal to +24. So what I would have to do here is undo the multiplication of -8 and x. So I would divide both sides by -8. Well, -8 divided by -8 is +1. 1 times x is x. And then 24 divided by -8 is -3. And what I want you to notice is, just in case you can't see it where I scribbled it out, we started out with -8x is less than or equal to 24. So we had a situation where the left was negative and the right was positive. Now we have a situation where the left is positive and the right is negative. We've had complete sign changes, okay? We divided by a negative. We can no longer use less than or equal to. We, the mathematicians, have to reverse the direction of the inequality symbol. So I'm going to put a little note here, reverse inequality symbol, and I'm even going to put an exclamation point, okay? So this right here is our solution, okay? As far as a graph goes, draw your number line, tell your reader where you want your boundary point or your end point to be, and then ask yourself, can I include exactly the end point? And the answer here is yes, you can. You can include exactly -3. So we use a square bracket. So we use a square bracket at -3, and then we want values for x to be greater than or equal to -3, so we're going to shade to the right. And this red piece is the interval. So the lowest our solution could be, that's going to be the left side of the right of the red portion of the graph. So that would be from -3, comma, just as kind of like we're going to go from -3 to whatever. Well, we can go all the way to the right, which is infinity. Can never include infinity. Here we must include the -3. So there's your graph and your interval. So nothing crazy when you're solving linear inequalities in two variables. You just have to remember this one little piece that shows up here in example 4, part B. As long as you're multiplying and dividing by a positive, nothing weird. If you're multiplying and dividing by a negative, you're going to have complete sign changes. And to compensate for those sign changes, we just have to reverse the direction of the inequality symbol. That's it. Okay, so I believe in the next video, we're going to practice solving multi-step linear inequalities. And then I don't remember what comes after that. We have solving inequalities with unusual solutions. And then we're going to look at three-part inequalities and then applications. Sweet, we've got a ways to go. It's going to be a long night, y'all. All right, so I'll see you back here to solve some more inequalities.